Okay, class. For the continuation of our lesson for the risk analysis, we will study this set of problem. Okay, so example, you need to construct a fault tree for the simple electric motor circuit shown below. So in here we have the switch, which is currently open, the fuse, and the motor. Of course, we also have the wire and the power supply. So in the fault tree analysis, take for example, the problem is the motor fails to operate. So we have this motor which is malfunctioning or it fails to operate, and now we are going to dive deeper on the reasons why it happens. So the first one is an OR gate. So it means that either of the two reasons might occur, but not both. Okay. So the first one is defect in motor, which is a primary event. So no need to explain this further. It just says that the motor is defective. And on the other side, no current to motor. So it means that no flow of electricity is present on the motor. That's why it fails to operate. And with this event, okay, it has some succeeding reasons which we are going to know more about using this causes. So first is the gate used was OR gate. So either of these reasons. So take for example, if the switch is open, no current to the motor. Okay. Wire failure will cause also no current to the motor, fuse fails open, and also the power supply failure. So we have two rectangle symbols here. So we have sub trees for it. So we have the switch open or gate as well, switch fails to open, or maybe the switch open erroneously. So we use diamond symbol because this is undeveloped event. So we need to ask help of the professional or experts on this field to know more about the details of it. Then on the next event, fuse fails to open. We also have the OR gate. So the fuse failure due to overload or the fuse failure under the normal condition. So that will be the a primary event. Unlike here, it has failure due to overload. It has some succeeding other reasons why. So we have used an inhibit gate here. So it is also considered as AND gate. So we use the inhibit gate together with the fuse fails open in a conditional or oblong or oval symbol. Okay, so they are used hand in hand. So for the overload in circuit, which is also in a rectangle symbol, we use the OR gate either while wire failure or shorted or the power failure or surge. Okay, so this is the entire fault tree analysis for the motor fails to operate problem. So we're going to dive deeper on this by determining all the minimal cut sets for the small motor problem. So when we say minimal cut sets, this is the smallest combination of the basic events which, if they occur, will cause the top event to occur. So those were the things that we need to monitor, because if it occurs, so probably the top event will also happen. Then the solution, let T denote the top event. So we have substituted the words here, or the motor fails to operate, with the letter T for it to be for our convenience if we are going to have a formula or to write the formula of it. P for the primary events, G for the rectangles, which are intermediate events, S for the undeveloped or the diamond, and C to denote the conditioning events such as the ovals. Okay, therefore T is equals motor fails to operate, P1, P2, and so on. So you can see it here. Okay, so we have substituted the relative acronym for it. Okay, P1, G1. So P1 is equivalent to defect in motor, G1 is equivalent to no current to motor, and so on. So in writing the equations for each gate of the tree, you can have this T, the G1, the G2, G3, G4, and G5. So to write the equation, or means plus, and the inhibit gate or inhibit symbol means times or multiplication, and it's also equivalent with the AND gate. So T, P1 plus G1, that's why we have this one. Also, the G1 is equivalent to P2 plus P3, G2 plus G3. Then for the G2, it is the sum of P4 and S1. For G3, it is the sum of G4 and P5. For G4, it is equivalent to the, take for example, we have the inhibit gate here, so it will be the multiplication because it is equivalent to AND gate. Okay, so C1 times G5. And for G5, G5 is equivalent to P6 and P7's sum. Okay. For using the top-down approach, we will get by the substitution. Okay, so T is equals P1, G1, and then going down, we have P1, P2 plus P3 plus G2 and G3, and then one level down, P1 plus P2 plus P3 plus P4 plus S1 plus the G3. Then later on, the G3 will be removed. We will have this formula. So instead of G3, we will have the G4 plus plus P5. Instead of having the G4, we use the C1 plus C1 times G5 plus P5. And then going down as well, one level down, so P5 plus C1 times P6 plus P7. Okay, and to add more details, so the lowest level, we have the same here, P5 plus C1 times P6 plus C1 times P7. So that will be the substitution for this fault tree analysis. Next problem is to calculate the probability of the occurrence of the top event. We're going to calculate the probability of the top event of happening. Okay, so assume that the probability of occurrence of each basic event is equal to 0.01. So that's why from P1 to P7, we have 0.01 probability. And the probability of S1, or the switch opened erroneously, is equivalent to 0.001 here. Okay, and also assume that the C1 fuse fails to open has the probability of occurrence of 0.5 here. Okay, now we will just use the lowest level of the formula that I have shown to you a while ago, and then substitute all of the probability present in this table. Okay, so P1 plus P2 plus P3, P4 plus S1 plus P5 will be 0.01, and also the C1 times P6, this is 0.50 or 0.50 times 0.01 plus 0.50 times 0.01, and the score or the probability of T happening will be 0.061. That's why it is plotted here. And we can also know the probability of the intermediate events happening by using this symbol, okay, and using the formula present on the previous slides. So the probability of this intermediate event to happen is 0.051, this 0.011, 0.02, 0.02 as well, and 0.01. Okay, so just remember, class, that if AND gate, we will use multiplication. If OR gate, we will use the addition. The inhibit is also equivalent to AND, which is multiplication as well. Okay, so thank you very much for listening, and hope you learned something new today. If you have question, you can just message me or email me at my email address. Thank you.